So today the student will be able to understand an nth root in order to simplify radicals. Whenever you see the letter, oh man, how do I get back? Okay, whenever you see the letter n, like nth root, that's just a variable to mean like, do you have the fourth root or the fifth root or the square root? So an nth root is, so if you have like, we all know a square root, but you could have a cubed root. So in that case, n is 3. You could have a fourth root. So n is 4. You could have a fifth root or a sixth root or a seventh root. That's what it means by an nth root. All right, so the nth root is for any real numbers a and b and any positive integer n. So if a squared or a to the nth power is equal to b, then a is an nth root of b. So for example, because negative 3 to the fourth power is 81, then negative 3 is a fourth root of 81. So that means if I took the fourth root of 81, my answer is negative 3. Or it could be positive 3, okay? In today's example, in today's notes, when you take the root, when you find the answer, you're going to leave your answer as just the positive answer, unless specified. So unless it has to be the negative, or unless it's given the negative, or unless it's an I. Okay? All right, so now let me explain how to do this. So our first example here says simplify positive negative square root 16, x to the 8th power. So our answer will be positive and negative because they specified it, because they told us we're going to use both. Now, we know that the square root of 16 is 4. Okay, and x to the 8th power, the square root of x to the 8th. Well, here's kind of what you're looking at. So if you took 16, you know the square root of 16 is 4 because 4 times 4 is 16. And you need two numbers, a pair for a square root. A pair will take it out of the square root, right? So if I figure out x to the 8th is really 1, 2, 3, 4, 5, 6, 7, 8 x's. So for every pair, I can take one outside. 1, 2, 3, 4 pairs. So I have 4 x's on the outside. And there's nothing left on the inside because everything paired up and could be taken out. Okay, but that doesn't look very good. So we're going to say it's plus or minus because they told us that. 4, x times x times x times x is x times itself 4 times. So it's x to the 4th power. Okay, so when you have an exponent, we got x to the 4th. You can write it all out and find how many work, or you can take the exponent divided by, this is a square root 2, because the square root, and 8 divided by 2 is 4. So my exponent has to be 4. Okay? All right, let's look at the next one. It's a negative, so our answer is going to stay negative. Q3 plus 5 fourth. So really what this is we have the square root of q cubed plus 5 4 times. Okay, now, these are all sets of parentheses, so I can pair them as that. So I have one pair of q3 plus 5, 2 pairs of q3 plus 5. So remember, a square root, really, you could write a 2 in there, in the root part, just like this one is a 5, it's a fifth root. So when we are thinking square roots, we're thinking pairs of stuff, any pairs of 2. So I have a negative that they gave me. I have 1 cubed plus 5 from this pair, and I have 1 q cubed plus 5 from this pair. So we took that q cubed plus 5, we took the exponent of 4 and wrote it out 4 times and found how many pairs we had. Or you can take your exponent, divide it by what you're doing. So this is a squared root, so divide by 2. And we know we're going to end up with 2 of them. Okay? So we could write this as negative q cubed plus 5 squared. Now, technically, you could take that, FOIL it out, and figure out the polynomial that it creates. But today we're worried about what happens straight out of the square root, or straight out of the roots. We don't need to do all that today. All right, next. Instead of having a square root this time, I have a 5th root. Okay, so let's talk about what that means. When you have a square root, you need a pair of the same thing to take it outside, because there's 2. A square root is 2. When you have a 5th root, you need 5 of the same things in order to take one outside of the root. So 243. I need to find something that multiplies by itself 5 times to get to 243. Okay, well, I've done some trial and error, and I figured out that 3 times 3 times 3 times 3 times 3 is 243. And because 243 is made up of 5 3s, then I have a 3 on the outside of my answer. All right, now, A10. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. A10 is really A times itself 10 times. And for every 5 set, I can take one outside. Well, I have 2 A's outside because there are 2 sets of 5 A's. Okay, so B's, I need to figure out, break them into 5s. 4, 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there are 3 sets of B. So the difference between having a square root and having a 5th root, when you have a square root, you're looking for pairs of things to take them outside of your root. When you have a 5th root, you're looking for groups of 5. For every group of 5, you can take one of them out. So I had 1 group of 5 B's, 2 groups of 5 B's, 3 groups of 5 B's. So I can take 3 B's on the outside of my root. So simplified, this is 3A squared B cubed. Or for the exponents, you could say that 10, the exponent of A, divided by 5, your root, is 2. So A should have an exponent of 2. You can take 15, your exponent of B, divided by 5, the root, and you get 3. So B is an exponent of 3, okay? All right, for number 4, we are looking for a group of 3 things. If I can find 3 things to give me negative 8, like the same 3 things, then I can take that out. Well, I know that negative 8 is the same as saying negative 2 times negative 2 times negative 2. I have 3 negative 2's, so I can bring a negative 2 out, and that's my answer. Now, don't get confused. There is no I in number 4. We've been doing a whole lot where if you have the square root of a negative, you end up with an I. Well, that's because it's a square root, but this is a cubed root. And if you have cubed roots, it's not impossible to get a negative inside of the square root. So there's no I in number 4. All right. Number 5, we're going to keep the plus minus. It's just a square root, so I'm looking for pairs. I know that 9 can be broken up into 3 times 3. So a pair of 3's gives me a 3 outside. I know that x to the 8, I could write it out 8 times and find how many pairs. So 1, 2, 3, 4, 5, 6, 7, 8. 1 pair, 2 pair, 3 pair, 4 pair. So 4. Or I could take the exponent of x8 divided by the type of root we're finding, 2. And I know my exponent should be 4. Okay. All right. This one, I have a negative. I know that. Now, this is a square root. And I have this whole thing to the 8th power. So I really have 8 a cubes plus 2. I'm going to use the shortcut this time. And I know that if I'm I have a square root, I'm looking for pairs of those things. So how many pairs will I have in 8 powers? If you take all 8 of the ones that you have and divide them by 2, you know that you have 4 pairs of that. So really you have negative a cubed plus 2 to the 4th power. So if you wrote it 8 times, you would be able to find 4 pairs. All right. The 5th root of 32x5y10. Again, I've done some research and figured out that 2 times itself 5 times is 32. So I have a group of 5 2's to get the 32, so I have a 2 outside. x5, all right, 1, 2, 3, 4, 5. That's one group of x's. I could do the same thing with y, or I can just divide. So if I took my 5th root, divided, or my exponent 5 and divided by the 5th root, I get exponent, sorry guys, I get an exponent of 1 on x, so I just have x. But if I take the y, exponent of 10 divided by 5, my new exponent is 2. So I have 2xy squared. All right, the square root of negative 16. This is different than the cubed root. If you have a cubed root of a negative number, you can do a negative times a negative times a negative and get something that's negative. But if I have a square root, there are no 2 numbers that will multiply to give me negative 16. It's impossible. So this is where you have to bring back your I. So it's square root negative 1 times square root 16. Square root negative 1 is I. Square root of 16 is 4. If it's an I, you always have positive and negative. So it didn't tell us positive and negative this time, but we need to write both of them down. So my answer is plus minus 4i. All right. One more little rule. When you have an even root and an even power and the result is odd, your answer will be an absolute value. And so let's say the result is an odd power. So we're still talking about the power or the exponent. So 6 is an even root. 6 is an even power. When I work this question, remember I can divide. So 6 divided by 6 is 1. T to the 1st power. So I have an even root, an even power. My resulting power is odd. So really my answer is absolute value of t. Okay? All right. This is a square root, so that's an even root. The square root of 36 is 6. That is what it is. But the y6, we're talking about those exponents, or on the variables. 6 is an even power. 6 divided by 3 to find the new exponent, or 6 divided by 2, sorry. 6 divided by 2 to find the new exponent is 3. So I have y3. Okay, I have an even root, an even power, and it left me with an odd power. That means this y cubed needs to be in parentheses, or needs to be an absolute value. All right. So my answer is 6 times the absolute value of y cubed. All right, last example. I need 6 things that would multiply to 64. Well, 2 times itself 6 times is 64. Oh, sorry. So, because I have a group of 6, 1, 2 can come out on the outside. Okay, now, I have all of this to the 18th power. So I can take this 6 and the 18th and divide to figure out how many I have left. So 18 divided by 6 is 3. So I have x squared minus 3 cubed. Okay, now, it's an even root, an even power, but it gave me something that's odd. So this needs to be in absolute values. So I have 2 times the absolute value, x squared minus 3 cubed. All right, you only have to look for that rule if you have an even root and an even power. Otherwise, you just give the sign of what they asked you for, like if they told you plus minus or they told you negative, or if it's I, you need both. So those are kind of the only special rules. All right?